Hello, in this tutorial I'm going to teach you how to use Gmesh to create a geometry and then mesh it into a finite element mesh. So two concepts here. One is the concept of geometry. Geometry is the shape, so we're going to create something like this, where the geometry is given by the outline shown in blue. It's the general shape, whereas the mesh is the discretization of the mesh. That is how we subdivide that mesh into finite elements. The finite elements are these triangles that look here, but they're actually tetrahedrons. So you can imagine that these are pyramids or triangular base pyramids. That is, they're defined by 4 nodes. They're tetrahedrons. So the way we subdivide this shape into tetrahedrons from the geometry is called the meshing or the discretization, numerical discretization of the geometry. So two concepts, geometry and the mesh of the geometry, are separate. Now Gmesh is used to prepare the geometry as well as to do the meshing, and then afterwards you can use it for post-processing. So in this step I'm going to show you how to create geometry, simple geometry using constructive solid geometry concepts in Gmesh, and how to discretize that into tetrahedrons. Now the geometry can also be imported. If you want to prepare it in some other program, that's fine. You can import it into Gmesh and use that for meshing and post-processing, or as some other part just for post-processing. Anyway, let's get started. So let's draw something like this. Okay. So right now I'm on Linux. So the way I fire up Gmesh on Linux. So after installing Gmesh on Linux, if you're on Linux, you can do something like this: install sudo pip3 install Gmesh, and that'll do it for you. And then after that executes, you can just run gmesh tutorial.geo. That's going to be the name of the file. On Windows, there might be something different you have to do to get Gmesh started, and on Mac it's going to be something different. So it's going to depend on your system. This is Linux, so I'm assuming that you can get to this screen, and that from here we can start. So when you're presented with Gmesh, this is what you see. Pretty much nothing. You can right click empty space here and enable the axis. So you'll see this box going from -1 to 1 on all 3 axes, and you can use the center mouse button and drag to zoom in, zoom out. You can also use the left mouse button to rotate, pretty standard, and then the right mouse button will allow you to, will give you the context menu, and there's something else you can do to pan. So the right mouse button, and if you hold it down, it'll pan. Okay, so we'll start by generating the geometry. Okay, so we're going to start with a box, and we're going to go here to this context menu over here, and we're going to add an elementary entity. We're going to add a box. Now when you add a box, you can click on the screen to do that, or you can use the dialog. With the dialog, you can have more control, so you can place the corner, the bottom left back corner of the cube wherever you want, and then you can freeze here. So if I freeze, say, X and Y, and I just get Z, the box will move in the Z direction. You can see down here that Z is towards my left. Let me rotate that so that we get Z up. So you can see up and down. Okay, and only the Z value is changing. I'm just going to freeze that too and set that to 0 and create a box of unit side like so. Add. You can also follow the instructions up here. Press Shift, hold position, and E to add the box. Okay, once we're ready with that, we'll abort. We'll press Q to abort. They'll make a box. Okay, that box doesn't look like much. Let me disable the axis. That box doesn't look like much. I can use the right context menu to go to the geometry options right here. That's also available here, tools, options. Okay, and if I go to geometry, visibility, I can set visibility for surfaces, and I'll get these ugly crosses representing the surfaces. I can change the aspect of the crosses if I go here to aspect cross solid, and that'll make something, give you something that makes more sense. Now those crosses are useful when you want to see inside the volume, so sometimes it's important to see inside. So in that case I'll have that enabled. And the other occasion, if you want to see inside, if I enable visibility for the volumes, you'll see the volumes are represented by these yellow spheres that just mark this interior volume as being a volume. Okay, so there's nothing much more than that to it. So I'll disable that. Now we're ready to mesh. This is a geometry. Okay, so the geometry, I can mesh any geometry. If you go to the mesh option and press 3D, you'll get a mesh. And if I go to the mesh option in the context menu, I can disable 2D element faces and just get 3D element edges and faces. And you can see it's been discretized into tetrahedrons right out of the box. So that's nice. So let's start doing more stuff. Okay, so let's take a look. Every time you make a change, the Geofile, you don't need to save it. So you'll see that there's not really a save option here. There's save mesh, which you can do when you have a mesh. But other than that, it's always getting saved. So let me show you. You can go here in the menu and geometry, edit script. So that'll open up whatever your default text editor is, and we'll show you what the Geofile is. The Geofile is a text file that looks like this, that has, in this case, two commands: set factory to open cascade. That's kind of default. There's two factories. Factories is the method with which you generate the geometry. There's two, like the built-in kernel, which is the original legacy Gmesh geometry module. It's good for some things. Open Cascade is a much more powerful method to do the geometry, and it'll get automatically set to that when you use certain options of Gmesh. Don't need to worry about this now. And then there's the command for you to generate the box. Okay, so the box will give you, these are commas, so you'll get the corner, the coordinates of this corner right here. So the first corner, you'll see that's labeled 0.2, and then the dimensions in X, Y, and Z. That's the command. So I could change any of these. Let's make it 3 times as large in the X direction. We save this file, then we can go back to Gmesh, we can close it even, and then we can reload script, and you'll see it'll generate a nice long box. The mesh is not there, you need to remesh, but then if you remesh, it's there. Okay, so let's edit the script and bring it back to what it was and generate more geometries. Save, close, reload. Okay, so that's looking good. So let's converge to what we wanted to. We need to pierce this with a little cylinder. So let's bring up the dialog for a cylinder, and here we're going to start using the concept of constructive solid geometry. So basically where you use elemental shapes to add them, subtract them, intersect them to generate a more complex geometry. That's the basics of it. And then you can do operations like scaling and extruding and rotating and those kinds of things to get more complex objects. So it's a very powerful method of generating 3D objects. So you'll find that your cylinder in this case is aligned with the X direction, which is what I want right now. I can align it in any direction I want. So the concept here is similar to before. Now the XYZ coordinates are the coordinates of the center of one of the faces. So in order for it to be in the middle, I'm going to set it to, let's see, we want it oriented in the X direction, so in the YZ plane, I'm going to put it in 0.5, 0.5, 0.5. There we go. And this is too big, so I'll bring the radius down to 0.5 to, sorry, that's not what I wanted to do. The radius is over here, 0.5, let's bring it down to 0.25. Something like that. Yeah, that looks good. Okay, so that's the cylinder. If I want to orient it in different directions, so axis dx, dy, dz will give me the height of the cylinder in each direction. So if I put it in the direction 1, 1, it's going to be going in that way, and the total length is going to be the square root of 1 squared plus the square root of 1 squared. That's square root of 2. If I put it to 0 here, it's going to go into that direction. So what I want to do is what I originally had, which is just a unit length cylinder in that direction. So let's just add that cylinder. And now when we go back, you'll see that there's actually 2 volumes here. I want to subtract 2 volumes, but you can't see them because the dots are overlain. So let me do a quick trick, a quick hack. I'm going to edit the script. We'll see the cylinder is added. So let's make the height a little smaller. I'll just set it to 0.5 for the meanwhile. Let's put it to something different, maybe 0.7. The reason for doing that is that I want to get the center of mass to move a little bit so I can select it. So let's reload the script, and you'll see that you have the center of mass for the cube and the center of mass for the cylinder. Okay, so now I want to subtract these two things. I want to perform a Boolean operation. Where I subtract the cylinder from the box. So let's do that. We'll add the Boolean difference. We'll do the Boolean difference. Let's do volumes here. So first I'll select the object that I want to subtract something from, and then E to N selection, and then I'll select the tool. That is, what is the geometry with which I'm subtracting. So let's select the cylinder, and there we go. Press E again, and then Q to abort. So when I mesh this, you'll see I pressed the hotkey 3. So 1 is for 1D meshing, 2 is for 2D meshing, 3 is for 3D meshing. You'll see that it was successful, but the cylinder did not go all the way through because I made it smaller. So let's edit the script back and change that 0.7 I left. I set it to 0.7 so that I don't confuse it with the 0.5s that are right next to it. So there, save, and we're going to reload. Reload is 0 on the hotkey, and then we can go 3 to mesh, and we can see that the cylinder goes all the way through. Okay, so next thing, let's see the command that got added. So let's quickly edit the script. You see the Boolean difference. What it does, you take volume 1 and you subtract volume 2 from volume 1. Volume 1 is the box and the cylinder is volume 2. And then you delete this. If you don't delete it, the original geometries are going to be there after the operation. Good. So now let's add another box that represents the direction, the hole in the other direction that I want to create. Let's do that. We'll add a little box. I'm going to go 0 so that I can see the inside. And we need the box to go in the other direction. So let's go 0, 0, 0, like this. And we'll make it of size 0.5, 0.5, and 0.5. I actually need to make it longer in the Y direction. So let's go all the way to 1. And now we can place it where we need it to be. So in the middle there, that would be in the XZ axis. We're going to put this in 0.25 and 0.25, like so. And there we go, add it. And there we have the geometry of the box. Again, the volume is right in the middle as before. If we mesh this, the box is meshed independently, so you can see the meshes don't match because they're independent geometries. They're not related in any way, apart from being in the same, occupying the same space. So I actually want to subtract the orange area from the green one. So let's do that from the script, from the GeoScript. So bring up the GeoScript again. And what I'm going to do is this little trick. The GeoScript is fun to think about it as a undo list too. If there's a command that you messed up in some way, you can just delete it from the Geofile and reload the file. So that's useful. So I'm going to move the creation of the box to the top, like so, and just give it a new number. So box 3. So we're going to have 3 volumes at the start: the box, the cylinder, and the other box. I'm going to erase these separators. They're kind of annoying. There we go. And then the Boolean difference, I'm going to do it between volume 1 and then volume 2, comma 3. So both those volumes at the same time. I save, I exit, and I reload. And when I mesh, you'll see that the hole is there. Okay. So for the last part, we're going to generate a triangle up here, and we're going to subtract that. The way we're going to do that is first we're going to create an equilateral triangle. So the base is going to be 0.5 and the height is going to be I'll show you right now. Okay, so let's go anywhere. We're gonna do it in the following way. So this is the mechanism we're going to do. We're going to add a point. We're going to add a point somewhere. Let's freeze the z-axis, and we're going to add a point there, and a point there, and a point there. So I have 3 points added, and those 3 points are going to specify my triangle. Okay, I'm going to add a line between those points, like so. Click, click to add 3 lines, and then between those 3 lines, I'm going to create a plane surface. So you select the plane surface, select the edge right there, E, and you'll get a new surface. And then that surface, you can go ahead and extrude it. So if I use the extrude command here with translation, I can select surfaces, select the little ugly red cross in the middle, and then we're going to extrude it by 1. Okay, so when I do E, I press E to end selection, it's going to extrude that, and then I can go ahead and close this dialog, press Q to abort. I actually think I'm going to need to restart this. So I'm going to reload the script, like so. And then when I mesh 3D, you can see it's independently meshed. So now what I need to do is to translate, well, get the shape right, and then place it in the middle. So in order to do that, I'm going to go actually into the editor again. Let's bring, there we go, the script editor. For some reason before, let's play. So the Geofile is kind of like C++, so that's why the coloring, if you set this to C++, it works. Okay, so here we have the part that belongs to the triangle. Okay, so the 3 points I'm generating, let's make sure we generate a triangle for those. So I'm going to generate A equals, so I'm going to give the side length of A, so that's going to be the base, and the height then is going to be square root of 3, square root with a capital S over 3. So that's the side, that's the height of the equilateral triangle. Okay, so in order for it to be a triangle, let's place it on the coordinates 0, 0, 0. So that's the first point. The second point is going to be towards the x direction at A, so the base length. And the final point is going to be in the middle in the x direction, and then add the height, whatever the height is, and then add 0. So if I reload the file at this point, we're going to see that the triangle has shifted and it looks like an equilateral triangle. Save, close, and reload here. So you can see the triangle is right where it's supposed to be. So let's go and mesh. Now I messed up something because it's not an equilateral triangle, so let's see. Let's open up the script editor again. Here's the script. What did I do wrong? Ah, this should be a 2. Square root of 3 over 2. Or is it over 4? I forget. Anyway, so reload script. It's going to be a longer triangle. So let's go, and it should be square root of 3 over 4. Something like that. There we go. That looks equilateral. Okay, so next, so if you mesh, the mesh goes there, right? We just need to move that into the position that we need, and then subtract, and then we're done. So let's, my Gmesh is a little bit buggy. I can't get rid of the select surfaces, so I'm going to close it and reopen. Like so. There's the geometry. I can mesh it. The mesh doesn't show everything I want, so let's enable faces and disable those faces. So we're going to bring up the script again, and we're going to want to move that corner. So we're gonna move it in the x direction. So we want it to be in the center in the x direction, which is 0.5 minus half of the side length, like this. And in the y, I want it to be placed in the center again, minus half of the height. So there, then I just add those points. I can just add those coordinates directly into the original coordinates of the points. So if I add dx here plus 0, dx plus like this. I'm going to be moving the whole triangle by that amount. I'll put dy here, dy, and h plus dy. So now I close this and I reload the script, and we get the triangle smack in the middle. Let's mesh 3D. And now we'll do the subtraction. So the same trick as before. We bring up the edit the script, and we'll move all this geometry before the Boolean difference right here, and we'll add the final volume, which should have label number 4. So let's do that. Close the script and reload. Hopefully everything works. There we go. And when we mesh, we'll get the original figure that I saw. Now what you can see is, because the tetrahedrons are planar faced in the side, the discretization, wherever there's curves, it's not going to be exact. So there's 2 ways to get around this. Use higher order elements, we'll see those later on, or make this mesh smaller. So if I right click and select here the global, what is it called? The global mesh size factor, set it to 0.5, that'll just cut every element side by 1/2. And then I can remesh. So I go 1D, 2D, 3D. And then the mesh is closer to the geometry. It's still not exact, but it's closer. That's how you can control global. As a final step, let's save the mesh. We'll save it as something. Save mesh. Once you press that, you say it'll show you the message here, saved as tutorial.msh, which is this file right here. But you can open it with an editor, and it just contains all the coordinates and all the information about the mesh. We'll see how to post-process that mesh file using Python scripting in the next video. Thank you very much.